Okay, just a quickie here before I get on to, I gotta do some threading and stuff. This is the lock nut or the clutch nut. You can see it slips on halfway over the diameter where the threads are going to be cut now. It's so stripped out. We're going to be making a new piece here, and that'll be the next project in mind. Now, this gear locks and controls the bell tones, their ringing, and when you loosen the nut, then you can adjust and slip so that the bell tones will match the time of day, daylight savings time, etc. Or silence the bells altogether by just letting it sit in a freewheel. Now this gear locks by pressure against this surface here and this surface right here. Deciphering how those threads were pulled and snapped off at the end here, I believe it's just a little bit of over tightening to compensate for pressures that are lost because of wear over the time period. This little mark right there is because the shaft it was sitting on was hitting harder than the disc was out in this area right here. So we're going to repair and compensate that contact area there so that it'll go back to normal operations with less tightening pressure by the nut. We confirmed a couple of things. This was cup shaped, and you can see the foggy ring right around here. I took it and just lightly rubbed it on some emery paper over on the stone so I can get a impression or contact, and then you can hold your scale up to it and you can see that it's concave, so it was getting contact all the way around, and the larger diameter contact, the easier the hold is. Okay, I'm going to put the threads in for that tensioning nut on the shaft here. I'm going to run through with a fast forward of how this thread is happening. I've got my mag base set here against the compound. I have it set at 0, and this is usually my my dashboard gauge. This is what I'm watching for controlling the amount of materials I'm taking out. Compound set at 60, and I set this at 0 because you'll see the difference between what we're actually getting here and what we're getting in here, which is a little bit more travel in at this angle to make the same amount of straight in depth. But I don't normally read this the dial, but if you don't have an indicator position or capabilities, then you have to rely on this. This dial is set at 0, and I have the handle set so that it's comfortable to pull out at the end of your thread. It is very important to get your tool bit out even, uniform, things like that at the end of your thread. Experience lets that come about. This lever down here you'll see me grab is the two half nuts coming together and creating the lineal travel at the pitch we desire for our threads. Alright, that's kind of simplicity of it, and so we've got the angle set. We've touched off the tool bit, just barely touching the outside. We claimed our 0 here, 0 here, 0 here. Alright, and this is how it goes about. You always want to verify your pitch. Make sure that you are cutting the right pitch. is done. Feels good. It is. I mean, it's, you know, it's free, no rocking. That's what you're looking for in a thread. All right, and we use that as a test nut. All right, so we'll make the new lock nut that goes on there, and continue on. All right, we got our steady rest backed off here. We wiped the oil off of there. This shaft is ready to come out, but we're just going to throw a quick polish on here so we remove our marks anyway. You know, nothing wrong with them. We just want to pretty it up. Okay, that's it. Just with respect to old items, antiques, collectibles, and everything else, you know, I clean the grease off of it, but I'm leaving the tone of color on all this. So when it goes back in place up on the clock there, we'll get a chance to see it, but it'll match everything else. It won't look like it's a new part. Of course, the nut we're gonna make is going to be new, and that will be a different color and things like that, but I just leave it alone. It doesn't need to be polished up to work right. This right here was just my own doings, and sooner, you know, it'll look like that. The rest of the metal up there that's exposed to the atmosphere. Okay, this is the chunk of material that we're going to use to duplicate this nut, and because this is just too far gone, threads are stripped out of there. These spanner holes are really worn. They actually, I think there's one of them that's actually got a crack starting on the side right there. That little crack right there. Alright, we've drilled and tapped here, and we're just checking our thread fit here. And we got a good thread fit. Now, because I want this part to run true, I'm going to go ahead and skim this OD and part it off right here in the lathe, and then all surfaces are running 100% true with those threads. These spanner holes, we'll go ahead and they'll be set up over in the mill, and we'll get those in at the same time. We're going to do that taper pin in the retainer collar for the pressure that this will push the gear against. Alright, I'm complete on this clock shaft now, and we've got it to go in a freewheel state, and we got it to be able to lock down now. So when they want the bell chimes to go, they'll lock it down. When they need it to adjust it or leave it in silent, they can leave this loose now. The cog that's over here controls the bell tones, and it ramps up here, and when it falls down to this position here, it's chiming the bells, and that's kind of how it works. We'll know more about this when we get a tour up into the clock tower, and we'll see this in place, and we'll see the inside of the other components there. Now, I don't know if this is going to be my ticket to heaven. Hey, can I at least get a get out of hell card? I don't know. This is a get her done. See you later.